Okay, and number 8, now we're going to do the cosine. And again, the cosine, you can get these values off your unit circle. And we would just plot those points first. It's just the cosine of x. That's our basic cosine graph. And what's the cosine of 0? Well, the cosine of 0 is 1. And the cosine of pi over 2 is 0. Mark this as 1 and negative 1. Sorry about that. And then this is going to be cosine of pi is negative 1, then back to 0, and then back to 1. So this is our standard cosine curve. It starts at 1, so it looks a little bit odd. We can get the symmetry if we want and keep kind of going over, but this is basically one period. And again, it would be going over like this. But anyway, that's basically one period. That's what we usually do when we're going from 0 to 2 pi. Okay? Now, I tried to keep this the same scale so you could see how they are relative. I couldn't do it on letter C, but letter B I could. Again, this is 1 and negative 1. Now, this is kind of a harder one, so to keep this in the scale is, like I said, it's a little tricky. Okay, so here we've got the cosine of 3x. Remember, the period is still 2 pi over b. All right? So b is going to be 3, so it's going to be 2 pi over 3. So that's my period. Now remember, whatever the period is, we've got to divide it by 4 to get 4 equal subspacing, or subregions, and those are going to give me my high-low points. So if I take 2/3 and I divide it by 4, or multiply by 1/4, I get pi over 6. All right? That cancels. That gives you 2 times 3 is 6. So that means each of those little intervals is going to be pi over 6. So I had to kind of eyeball this. So this is pi, keeping the same scale. This is pi. So I divided it into 6 equal parts. So this is pi over 2, so that's 1/3, 2/3, 3/3, 4/3, which is 2 pi over 3, 5/3, and 6/3, which is 2 pi. So that's my 2 pi over 3, so that's actually one period from there to there. So keeping it in the same scale as the other problems. And we'll do the same thing. Remember, at 1 I have cosine of 0 is 1. Then I go down to 0, then I go down to -1 here, then I go back to 0, then I go back to 1. So now it's going to look like this really compressed cosine curve. And then there's one period, keeping the same scale as the previous problem. So you see the frequency is really going to be it's going to be a higher pitch, much higher pitch than the normal curve. And then you could just keep doing that, but that would give you one period. Okay, so that's a little tricky to keep it in the scale. All right. Okay, over here, letter C. Basically, we have a good old cosine, except now the amplitude is doubled. And then we're going to have a shift. So what I'll do is I'll just graph this part first, 2 cosine of x, and then I'll shift it. So the cosine of x normally starts here. Now I had to rechange my scale, so sorry about that. I didn't draw another graph, so I'm using these graphs to make it a little bit easier for you to see. So I had to change the scale now. So here my amplitude is 2, so I'll start there. My period is still going to be 2 pi as usual, so I don't have to worry about that. So I'll start there at 1, 0, -1, 0, and 1. So that's my normal cosine curve, but only with a amplitude of 2. But now I'm going to have to shift this up, or I'm sorry, I'm going to have to shift this down 1 because it's -1. So all I do is take each point and I go down 1. So start here, I go down 1. Go here, I go down 1. Here, go down 1. Here, go down 1, and here, go down 1. And that's going to be those are going to be the points I use. So it goes like this. There you go. So that's what it would look like. Now again, we had to change the scale, so that's where we have a little bit of a corruption there. So that's what it would look like. Shifted down 1. But you can see the amplitude. If you draw a line right down the middle, like this, you can see the amplitude is 2 units here. Okay? And the last one, negative cosine plus 1. Well, first of all, we'll do negative cosine. So we'll graph those cosine points in pencil. Remember, the cosine of 1 is 1, but then I'm going to take negative, so that's going to be negative 1. 0 stay the same. And then the cosine of pi is usually negative 1. Now it's going to be negative 1, which is positive 1. I'm back to 0, and then this is 2 pi is normally 1, but now it's going to be negative 1. So this would be what the cosine of negative 1 would look like. It's just kind of flipped over the x-axis. But now we want to shift it up 1, so I'm just going to add 1 to each of those points. So we add 1 to here, so this becomes add 1 to there, add 1 to there, add 1 to there, add 1 to there, add 1 to there. So those are your points that you're going to actually use. And remember, it's flipped upside down, so that's why it's going to look a little strange. So it's going to go like that, like that, like that, like that. And that's what it looks like. So it goes up like that, changes concavity there, and changes concavity there. We'll talk about those later. And that's what it looks like. So it's kind of flipped and then it's shifted up. Okay? So it's a little more complicated. I hope that makes sense. That's what you got.